In this video, I'm going to go over the modulus and argument of a complex number, how these relate to what's going on the Argand diagram when we represent these complex numbers on the Argand diagram, how we can find the modulus and argument of when we multiply two complex numbers together, and also look at modulus arguments form and see how we can write a number in modulus argument form if we're given it in the form x plus yi, or vice versa if we're given it in the modulus argument form, how we could go backwards and find it in the form x plus yi. So firstly, let's just talk about what these mean. So let's consider we've got a number z, which is equal to 1 plus root 3i. So the real part is 1, the imaginary part is root 3. If we wanted to represent this on an Argand diagram, so just as a reminder, an Argand diagram is simply two axes, where one axis tracks the real number part and the other axis tracks the imaginary part. Because we can represent complex numbers on a single number line, but if we make a two-dimensional graph such as below, such as the Argand diagram we've drawn, then we can. So our number z would be 1 across on the real axis, root 3 up on the imaginary axis, something like this. So if I was to label it, I'd just make sure I'm labeling something the axis so it's clear, and we'd have z there. So if we're asked for the modulus of z, this always means just what distance are we from the origin. So it's asking us this distance here. Now to find that, we can just do straight up Pythagoras, because really we've got a right angle triangle to work with here. I wouldn't normally worry about drawing this onto the Argand diagram, but this length's 1, this length is root 3. So the modulus is going to be the square root of 1 squared plus root 3 squared, which is just 3, and we'll get root 4, or 2. So the modulus of z is 2, because it's got a distance of 2 from the origin there. Okay, what about the argument for this number then? So the argument when we talk about this number is measured anti-clockwise from the positive real axis. So the angle we're talking about here is this angle in red here. Once again, we can go to the same right angle triangle. So this is root 3, this is 1, and just do trigonometry, and the argument of z is simply going to be arctan or tan minus 1 of root 3 over 1, which if you know your special values, you'll know that's pi over 3. So that's our modulus, and that's our argument of a number. I wanted to just look at one more, because what happens if we don't have a complex number in that quadrant? How do we deal with the argument in that case? So let's consider we've got w, which I'm going to say is 3 subtract 3i. So I'm going to draw a fresh Argand diagram here, otherwise my scale is going to be slightly off. But 3 across and 3 down, we're going to have somewhere like this. So because the imaginary part's negative, we're now in this quadrant, and that's going to be our complex number w. The modulus of w, we're going to find exactly the same as before, because using Pythagoras, it's just going to be the square root of 3 squared plus 3 squared, which is root 18, or alternatively you can write as 3 root 2. Either form should be fine, but I'll leave it exact. For the argument of w, now, we said, so we're looking at here, and we're looking at angle. I said we want to go anti-clockwise from the real axes, but if we do that, we're getting this huge angle here. Really, when you're asked for an argument, we're always going to state the argument of a number between, or the principal argument of a number at least, between negative pi and pi. So we're going to be given our answer in radians, and at the moment, if I was to find that massive angle I've drawn in, that angle's bigger than pi, because pi is 180 degrees. I've gone through more than 180 there. So rather than going for that angle here, sorry, I didn't mean to get rid of my axes there, but rather than going for that angle there, what we're going to want to do is we're going to want to look instead at this angle here, and because we're going clockwise though, we're going to give our answers a negative. So looking at this triangle, well, this is a nice isosceles triangle here. So that angle would be 45 degrees, or pi over 4. But in order to show that we've gone down, we've gone clockwise rather than anti-clockwise from the real axes, we're going to state this as negative pi over 4. If you had, I'm not going to go through the whole example again for finding more arguments, but if you did have a situation where you had a complex number z, say over here instead, you'd want to be stating this angle, so you'd be given an angle somewhere between pi over 2 and pi, and you'd probably better to find a small angle first by doing trigonometry, and then take your answer away from pi. So that's how you can adapt it to being in the other quadrants, but there's nothing too complicated going on there. As long as you're giving your answer between negative pi and pi, you should all be good. Okay, so what results do we have about the modulus and argument? Well, if I asked for the modulus of z times w, you could do your z times your w, work them out, and then find the modulus using Pythagoras exactly the same as before. But the results that you want to just be able to state and use is that the modulus of zw is just the modulus of z times the modulus of w. So this would just be, in this case, 2 times 3 root 2, and your answer would be 6 root 2. So the distance away from the origin of your answer of zw on your Argand diagram is just those two distances multiplied. The more unusual, and that might feel fairly intuitive, the more unusual one is the argument of zw. In order to find that, we want to do the argument of z plus the argument of w. Note there's a plus there, not a times. I think this is where our intuition might fail us, and we just see a times and automatically do that. The arguments add when we multiply the complex numbers. So in this case, we'd be doing pi over 3, and then we can either write this as plus negative pi over 4, or just subtract pi over 4. So the argument there would be pi over 12. If you were asked to now draw ZW on an Argand diagram, then we wouldn't need to work out what the two parts were originally. We know we're looking for a point where the angle anticlockwise on the real axis is pi over 12. So that's going to be a fairly small angle there. I'm just going to label as pi over 12. And where the length is 6 root 2. So if I was wanting to label ZW on an Argand diagram, if I've labeled those two bits of information, it's summing up where we are. Just make sure you think about the size of the angle when you're doing that. You're not going to be expected to draw pi over 12 perfectly, and I've probably drawn it too big. But I've not labeled the scale, I've labeled the angle. It's clear what's going on there. I now want to look at what modulus argument form is. This is a phrase that gets used and you need to be familiar with. You might be asked to write a number in modulus argument form. So let's think, just in a general case here, let's imagine we have a number z where the modulus of z is r and the argument of z is equal to theta. Well, I'm going to consider the simplest case first off for deriving this, but it will extend. So what this is telling us is z is at a point where this distance is r and this angle is theta. By doing a little bit of trigonometry here and making our right angle triangle, then the real part of this is just going to be r cos theta, and the imaginary part is just going to be r sine theta. So this tells us that we would be able to write z in the form real part, r cos theta, plus I lots of our imaginary part, which would be r sine theta. The more common thing we do now, we can see we can factorize r out, so we can write z as r brackets cos theta plus I sine theta. This is what's considered modulus argument form. So if you're asked for that, find your modulus, find your argument, and substitute straight into that. Only thing to watch out for here is this needs to be a plus here. So make sure you get in the form. If you're given something with subtracting there and you're asked to change it to modulus argument form, draw your diagram, work out what the argument is once you've got there, and go back. So it's just worth watching out for to check that's thrown in every now and then. But most of the time you'll be given it in this nice natural form. Thank you very much.